So now we're going to move into volume by shells. So we're still going to do the same thing. We're going to take things and wrap them about axes. They're going to be a little different. So let's check it out. So let's say that we have some function. It looks like this from A to B. So that means we're dealing with everything in terms of x's. And then we're going to wrap it around. We're going to wrap it around. Shitty drawing. Well, you can see the picture. I don't know why I'm doing all that, but we're going to revolve it about the y-axis. So now we're in terms of x about the y-axis. That is the complete opposite as how we did it with washers and discs. If it was in terms of x's, we went about the x-axis. In terms of y's, we went about the y-axis. But now we're going to switch it up. And when it's in terms of x's, we go about the y-axis. And if we're going to go about the x-axis, it means we need everything in terms of y. So let's just keep going. This is an intro, no problems. So what's going to happen here is we're going to take little pieces, right? Some little delta x, some thickness of the piece. All right, and then we have a function as its height. So it creates some little, I don't know, shell, I guess, is what they call it. It still looks like some sort of like disc or something, but everything's going to turn out a little bit different. So they called it a cylindrical shell with height. The height is f of x, and its thickness is delta x. I left a sub k star out of there. Let's just keep going. So it tells us that our volume is going to be equal to approximately the sum from k equals 1 up to n of 2 pi times x sub star k, and then f of x sub star k times delta x. And you're like, what the frick? What is this? Well, let's see why. So that shell has a thickness. Its radius is x. The radius is the x value. Huh. But it's kind of not. Now, what's the circumference of it? Isn't that 2 pi r? The circumference is 2 pi r. I'm like, why are we doing this? 2 pi r is the circumference. The radius, or 2 pi x. And the radius is just x. Let's keep going. Let's see what's happening. Oh, it's if you take that whole shell and you lay it out like a piece of paper, the height is just the f of x. The length, well, that's the circumference of that circle, 2 pi x or 2 pi r. And the thickness is delta x. Don't worry about the thickness. We'll deal with that with the integral. So here is our new formula that we're going to have. We keep on moving down. And we see that, well, we had it all in terms of sums where it was 2 pi times x, 2 pi r, that's the circumference, times the height, times delta x. But as we take that limit as n tends towards infinity, we end up with our formula. 2 pi x times f of x from the interval from a to b. So what do we end up with? What's our piece? Oh no. Oh no. There's our formula. You want to find the volume, and it is from A to B. Well, actually, I'd write it like this and make my life a little bit easier. 2 pi times the integral from A to B of x times f of x dx. So this again, everything's in terms of x, and we want to go about the y-axis. We're going to do it in this manner. All right. But since we're here, let's just get it all done. Let's deal with the other thing. Well, what happens if you have a top function and you have a bottom function? Well, there's some distance in between them. That's the difference in the height. That's the difference between the f of x and the g of x, where we would just have to subtract them out. But the radius will still be x. The circumference will still be 2 pi x. And then we're going to multiply by the difference in the f minus, or the difference between f and g. getting to this point. And here's our generalized piece. Let f and g be continuous functions with f of x greater than or equal to g of x on a closed interval from a to b. If R is the region bounded by the curves y equals f of x and y equals g of x between the lines x equals a and x equals b, the volume of the solid generated when R is revolved about the y-axis. Notice everything's in terms of x's going about the y-axis. We'll take that shell circumference, 2 pi x, and we'll multiply it by the difference in the heights, the shell height. And that's going to be our new formula. So this is when we have two functions. And once again, when we just have one function, it's going to be 2 pi times a to b of x times just f of x dx. So that's just a simple one where we don't have two different heights, where we're not trapped between two curves and going about the axis. Here is our intro. My goodness. That's a lot, huh? That's a lot. So next problem, we will get into it and we'll actually start doing some. Not just an intro. 6 minutes of me going, look, hey, see the thingy? See the thingy? Did you understand any of the stuff I talked about? Or are you like, oh, clearly I haven't? I don't know. I was never very good with the, show me, why it all worked. I needed to know how it worked. I needed to do a few problems first. And then I could start to figure out why it all worked out. So let's jump into our next one. Let's see what's going on. So we'll do one example problem in the next, and then we'll do some other stuff a little later. Bye, bro.